Okay, so this is our project, which is using GitHub YAML and Markdown to enable distributed and federated data discovery. So, the basic idea here is that there's different points in the life cycle where you can apply metadata curation. You can do it kind of retrospectively, where you kind of like go back to existing data sets that are referenced in papers or in various repositories, and you can go back and curate metadata about them. Or you can kind of like push it a little bit forward, and you can do your metadata curation by the submitter at the time of submission, maybe with help of kind of like dedicated curation staff. But I think I agree that the ideal way to do this is to do this prospectively and to describe the metadata as you're actually generating the data. And so the kind of observation underpinning this project is that for a number of kind of like projects in areas of science like genomics, people are increasingly using kind of like these social coding repositories like GitHub, GitLab, that most of us are familiar with as a way of depositing our code. But you can also use it to manage your data files and various kind of ancillary files, such as tools to run analyses on your data and so on. And so even though your average scientist has probably never heard of GitHub at the moment, there is a kind of minority of scientists who are actually actively kind of like using GitHub to kind of like manage these files as part of their analysis and data generation. So the goal of this project is to actually make the metadata capture more part of this data generation process by kind of targeting, and the idea is target groups of investigators who may be using something like GitHub, and make it kind of like easier for them to describe their metadata. And if you're kind of like maybe skeptical about the idea of scientists using GitHub, Daniel MacArthur is maybe not your typical scientist, but this is a nice kind of tweet he had, just showing how all of the figures from his XAC paper could be kind of like regenerated just by cloning their GitHub repository and running the R scripts in there. So I think this is just a nice way of showing how kind of like the culture is kind of like starting to embrace some of these kind of social coding mechanisms. So at the last all hands, I kind of gave a kind of like a conceptual overview of how it would work. So this time we've actually got something implemented. So I'm just going to kind of give you not exactly a demo, but kind of a walkthrough of how the system works. And so the basic idea is, you want to describe your data, you're starting a new project, so you kind of like go and you create a GitHub repository using one of our existing templates. Then you describe your data using YAML, which is a nice kind of like human-friendly, but at the same time expressive syntax. And then you can just start publishing your data locally on GitHub using a mechanism called GitHub Pages. And finally, the idea is this makes it easier to kind of harvest this metadata, both kind of like continually as the project goes on and at the completion of the project. So you can actually kind of like try this as well if you like. There's a short bit.ly URL, just bit.ly/ and I just went to the name mybiocaddy just now. If that's not okay, I can change it. But this is still kind of a pilot project, obviously separate from the main biocaddy. And if you go here, it's not particularly useful. It's completely fake. The idea is it's a template. So you go there and you click the button that says fork me, so you can fork the repository. Takes you here, and you can see the other forks that are in existence. And I took this screenshot with me going through the process here. So I forked the template repository into my own user space. So in GitHub, you have your own individual user space where you can keep all your repositories, or you can also have kind of organizational user spaces as well. And it comes just with these two fake files just to kind of get you started. But the idea is you kind of like customize those or replace them with your own data. So the idea is you describe, you have a file for every data set, and you just have a little free text description of it down at the bottom, and you can use Markdown syntax, which gives you a way of kind of like embedding URLs. And then you have what's called the front matter, which is this little section at the top between the dashed lines. And this is structured information in YAML. And And just to kind of acknowledge that this is still pretty kind of like hardcore geeky for many scientists, but you can imagine kind of like tools. The tools kind of for working with it are getting better, and you can imagine what tools layered on top of this. And so essentially the YAML format is kind of like a tag value format that can be nested. The idea here is it's a relatively kind of free-form vocabulary of tags. You can customize your own what's called a JSON LD context file that maps the different keys to an actual kind of like URI that represents the RDF predicate for the field. So even though what we have here is just say a field called title, behind the scenes this maps to the Dublin Core vocabulary term for title. So you can do the same for the actual values as well. So for example, we're describing a human data set here, and so we're using the ID NCBI taxon colon 9606. Then we get around the whole kind of like prefix issue because there's a default kind of set of ID prefixes that can be managed within prefix commons that maps NCBI taxon to the OBO Perl for NCBI taxon. But if you want to use your own prefixes, you can kind of like use a different set of prefixes from prefix commons. So this is the Perl for human here. And so one thing that's quite nice is as soon as you commit that file and push it to GitHub, you have your own little mini kind of like personal website that you can kind of like customize. And this all works due to the magic of GitHub pages. So I want to emphasize there's nothing, I didn't use the hardware costs for this project were zero. I did everything on my laptop and just what GitHub gives you for free. So it all goes up on GitHub pages. It gives you a kind of URL that is your name, github.io/myobiocaddy. And within that, you can kind of like browse your data sets and see the metadata kind of like at the side there. And this is not an awesome kind of like work of design, but you can imagine this being kind of like extended. And the idea is people can kind of customize the sites themselves. So one quite cute feature of GitHub Pages is it's very easy to add a kind of like discuss kind of like comment thing. So you can have little comment threads on each of your individual data sets as well. So some comments on someone's described the XAC gene list from the XAC paper. So after a while, the idea is lots of people do this, and just across GitHub in a distributed way, you've got a bunch of different repositories with people kind of describing either their own data, or maybe they're pointing at kind of external data, they're kind of crowdsourcing the metadata description. So how do we actually kind of like search this? Well, GitHub provides an API that's quite powerful, so we search for kind of like a magic symbol that we embed within the kind of like the source template repository. The API kind of gives you JSON, which is not very good for your average scientist looking for data. So we have a kind of like, just as a proof of concept, a kind of a harvester that uses the GitHub API, pulls in all these different repositories, and you can imagine everything below the kind of like the green box here as being something that would eventually be subsumed into BioCaddy if this proved to be a kind of like a useful way of doing things. But just as a proof of concept, we implemented the kind of like the full stack here. So it kind of harvests these repositories, extracts the YAML out of them, converts them to JSON LD using the JSON LD context that can be pulled from prefix commons or people can customize. Because it's JSON LD, it's automatically turtle RDF, and you can just load it directly into a triple store. And just as a proof of concept, we make a kind of an aggregated repository as well. So this is an example of just the aggregated JSON file with the JSON LD context at the beginning. And it says that I should be talking to kind of Harold about some of this as well, because we're thinking in similar ways. And there's a kind of a triple store that you get for free as well. So here we can just say, query for all data sets in NCBI taxon 9606, get their titles, and yeah, it's fairly kind of like standard, but this was just nice and easy to set up just because of the kind of lightweight framework that we have. And then this site is kind of similar, but it's really just an aggregation of all of the individual kind of like Markdown files that have been distributed across all of GitHub. And again, you can see the list down there. And it's not GitHub Pages a static site generator, so you're kind of quite limited in, you can't do any of the nice kind of faceted browsing or anything like that you see in the main BioCADI data med, but obviously this could be incorporated in. So I think that's as far as I like with the milestones for this meeting. Maybe just in the interest of time, I'll just kind of quickly go over to some of the things I'd like to do in finishing up. I'd like to just coordinate a little bit better with what Workgroup 3 has been doing, and mapping, being more conformant with DATs there, and also prefixes, identifiers, is what Working Group 2 has been doing. The pilot data sets we've got are a bit sort of ad hoc at the moment. They're just kind of like different people kind of contribute things from all over the place. I'd like to do something just a bit more coherent and let it run for a while longer. There's some bugs that need to be fixed. But, and after that, just do a kind of an evaluation of the whole process. Like, certain things were quite nice and flexible about using GitHub, but others, we ran into a few problems. You get into some kind of obscure issues there. And also, we don't want to make this whole system so that you're locked into GitHub. The idea is you could use a kind of free open source alternative like GitHub, GitLab or something. And then if, after the evaluation, if this seems like a useful mechanism, how can we kind of like integrate this as one component of the harvesting within DataMed? So, I'd mainly like to acknowledge BioCADI itself for kind of providing the seed funding for this pilot project. I love the work LBL was started out by Nicole Washington, but then she unfortunately got pushed by industry halfway through the project, so we had to kind of like scramble a bit, and I got a lot of help from Melissa Handel's team at OHSU. And a lot of this work is kind of like based on ideas that came from a project I work on called the Global Biotic Interactions Project with Yorick Cullen, and he had a lot of the initial ideas for this way of kind of distributing metadata across GitHub and indexing it. So yeah, I'll take any questions now.